Welcome back, chemistry fans. Today, what we get to do is finish up our unit on stoichiometry. What a difficult unit this has been. Very excited to have it end on such an easy note. We just kind of leave out with like a lamb. So we went in like a lion, now we're coming out like a lamb. And so what we're going to do here is talk about something called percent yield. Before we get into the actual math calculations, we need to build up a little bit of baseline knowledge, a couple of terms that I want to share with you first, and then we will jump into the actual practice. Okay, so first term that you're going to run into is actual yield. I would like for you just to understand the actual, that is the wrong value. And I know that the terminology may sound, well, how can it be wrong if it's actual? So this is your lab value. And labs, as you know, they don't go the way you plan them always. And so the actual yield is what is produced, and we're going to compare it to the theoretical yield. So that's the second term. Theoretical is the maximum amount that could be produced. This is the correct value. This is the stoichiometry value. So theoretical sounds like it could actually be somewhat wrong, but the reality is that terminology means that it's the mathematical calculated value. So this is the stoichiometry value. Now, what we do with these two terms is we're going to plug them into an equation called percent yield. Percent yield is the opposite of percent error. So before, we have had the formula for percent error. That is wrong minus correct divided by correct times 100%. Well, if your error came out to be a measly 10%, that would mean that you are 10% wrong, but that would mean that you're 90% correct. Well, that's what this percent yield is going to be about. It's going to be about you calculating how much you're correct, not how much you're wrong. So the value ends up being, or so the formula ends up being the wrong value versus the correct value. Wrong divided by correct. And we're going to then multiply it again by 100%. If you were to take the percent error and the percent yield together, you would end up with 100%. All right, so let's jump into how do we get this calculated. So we're going to have a normal stoichiometry problem. Nothing is going to be new for us as far as the technique. We will be given one reactant. We're not going to be given the two reactants like we were whenever we were doing a percent, whenever we were doing the limiting reactant. Now, if there were two, you could go through that process, but I'm going to keep this the same consistent path. I'm going to leave limiting reactants with two reactants, percent yield. I'm going to try and get that down to one reactant. Okay, so then we just stick it into the formula after we've solved it. They will always give you either the correct amount or they will give you the wrong. They will give you the theoretical or they will give you the stoichiometry, but it wouldn't make sense for them to give you the stoichiometry because then there wouldn't be much to the problem. It'd be just plugging into the formula. So more than likely what's going to happen is, just like in this problem, they give us the actual value. So this is the actual value. So we're going for the percent yield, but let's go ahead and see what the theoretical yield is in this problem. Sorry, that's not the actual. This is the starting amount. I read that wrong. So this is what we're starting with. I put that in the wrong place again, 24.8. So I've got 24.8. It's still my starting amount, but I put it in the wrong place. Okay, now what we're going to solve for is the theoretical yield there. Sorry, we have one reactant. We will solve through stoichiometry for the one product that they are asking for. Then we're going to compare it using the formula to 13.1. So we got to go and we've got to go and add up the weight of this calcium carbonate. 40 for the calcium, 12 for the oxygen, 48 for the, for the carbon, and 48 for the oxygen. So 40 plus 48 plus 12 gives us an even 100. So I've got 24.8 divided by 100 equals X over. Now I've got to add up my weight for calcium oxide, and that's going to be 56. So I cross multiply, and this will be my theoretical value. This is my correct value. So 24.8 times 56 divided by 100, and I get 13.89. Well, that's pretty doggone close to 13.1, but 13.1 was actually produced. That is my actual value. My 13.89 is my theoretical value. This will give me 0.94. I multiply by 100%, and what you get is 94.3% yield, meaning, oh my gosh, meaning that we are about 5.7% in error. Not too shabby for a practice problem. Okay, so I believe that this is everything that I'm wishing to share with you today about percent yield. Hopefully, we can knock this out and get ourselves over to the lab again today. Thank you for staying around. I'll talk to you again soon. Bye-bye.